If everybody could please go ahead and pull out the worksheet that we did last time. At the top it says pins outside observations. And while you're doing that, can you also take a look at the PowerPoint and please let me know if you cannot see it, if the font is too small or anything like that.
It looks like I just had it.
Looks like this.
This
But hopefully with your actual written observations.
Oh, I got it. Okay. I don't know what that is.
Alright, does everybody have it? Yay! Alright, so if you're a blue sticker, can you please come grab a blue marker and then put a circle of where you're standing from the outside activity right now.
What was Myra?
So what were you?
Zoe.
So.
Zoe?
I was in the outside circle.
Oh,
Okay.
she's green.
Were you blue, Shauna?
Yes.
Okay.
Well, you were green, right, Zoe?
Whatever color was the electron, yeah.
Why are you doing two?
It's just one circle for Crystal. Okay, perfect. And if you are a red circle, please come up and do the same. Lovely. And then if you are green,
Will you write Myra's? She's doing something.
yeah. Oh,
I got it. Black? I got the green. Oh.
thank you
Those
guys.
circles are so good.
Okay, so just to recap what we actually did outside before we go further into the explanation. So we had assigned stickers and we had the blue stickers stand inside of the solid circle as well as the red stand inside the solid circle. And then we had the green stand on these dotted outlined circles. And then if y'all remember, after we took observations of where you're standing in location of this solid circle as well as the other colors, we had the greens start walking around the dotted lines that were there. So if you can look at your outside observations, did the green people come closer or further away from the inner circle while they were moving? Oh, we need the sticks. So keep thinking of that and then I will call on somebody.
Oh, okay.
So,
Of all people.
can she hear?
Joe?
She says they never touch the middle.
Did they come closer or further away while they were walking around?
No.
Okay. And then, why didn't the two green people run into each other when they were moving? Crystal.
I was looking at them.
I already answered it for you, sweetie.
Oh, okay.
Why didn't the blue and the red?
No, so when the greens started walking around, why didn't the two greens run into each other?
Because they were each in a different orbit.
Perfect. Okay, and then the last question for review, does this model look like anything you have seen before? Miss Shauna.
I believe my handwriting says solar system.
Perfect, and why did you say solar system?
It felt like the middle where I was seeing since I was blue was the sun, and those were the planets going around.
Okay, perfect. Alrighty, well, thank you guys. I'm gonna turn it over to Miss Hernandez.
Hi guys, I'm Miss Hernandez. I think we already went over Adam. So we said, what does all this make? And what did we say? Anyone? An atom? So this is what an atom looks like. This right here, starting from the outline of this fuzzy circle all the way to the end. And then we said an atom is the basic unit of an element, and then that should be written in your definition of an atom. And you'll already know what an atom is because they'll cover that in 6th and 7th grade. And then we also said 99 point, all these 9s and then a 6% of the atom is made up of empty space. So this gray fuzzy stuff, a lot of that's just empty space where there's a whole lot of nothing going on. And then, then we also said subatomic particles make up an atom, but we didn't get to what subatomic particles are. And I believe we also talked about a common misconception. Does anyone remember what the misconception was? Can you raise your hand? The video. Does anyone remember the video?
Going up super small.
Mm-hmm. Nope. Okay,
The
let's go.
oxygen?
Yeah, the oxygen video. Real quick, I'm gonna play that. So a common misconception is that they don't realize how small. What is it? There we go. Okay, yeah. So a common misconception is people don't realize how small an atom actually is. So we're going to watch this quick video just to understand how small an atom actually is. And this is just a girl. We're going to zoom on in. Can y'all see that, or do y'all want me to turn the lights off? That's good.
Just check it, because sometimes I find it's triple.
The what?
Right there is where we stopped. Okay, so just notice that all of this, remember that fuzzy space we saw in the picture earlier? This is that fuzzy space, all this right here. And so this whole thing is an atom. So it is pretty small. Okay, so part of the definition was that subatomic particles make up an atom. So, actually we'll come back to that. So first I want y'all to think about what y'all did outside. So on the board, this picture is just blown up onto the PowerPoint. So the whole slide, this whole white part makes up an atom. So then the two people on the, who is green?
Zoe.
Myra and Zoe. Okay, so Myra and Zoe, y'all were outside and y'all walked along this kind of path, right?
Yes.
Yeah? So that is what we call the electron cloud. So your definition for the electron cloud is the part of the atom that comes before the nucleus. And I'm about to tell you what a nucleus is. So it comes before the nucleus. It's all that empty space where there's a whole lot of really nothing going on that we know yet. And then the next part is the nucleus. So the nucleus is the center part. So let's go back to this slide real quick. You see that little dot? That's how far the nucleus is in the atom. It's really deep in there. All that fuzzy stuff is just the electron cloud. So raise your hand if you were blue or red. So you were inside the nucleus, and this black line represents the nucleus. And let's see what our definition. The nucleus is the central part of an atom. So notice this space where there's this electron cloud all the way to the nucleus, because that is a common misconception, as well as, so we drew a circle outside, which y'all were in, and that was just for demonstration purposes. So a misconception is that there's this circle kind of around the nucleus, when actually there's not. It looks like that, where there's just these dots in the middle, and I'm going to tell you what those dots are in just a second. But where are these dots in the middle? So let's take away the circle, because it's not really, we don't really need it. We only needed it to help us get to what a nucleus is, so I could show y'all. Okay? So on your next page, or on the next part, let me see. I want you to take, I'm going to give y'all 1 minute, and y'all are going to individually answer what color were you. Were you inside the circle or outside the circle? And things like that. The next question, do y'all see that? So I'm going to give y'all 1 minute to answer those questions. And then put your hand on top of your head when you're done. Yay, everybody's done. Okay, so I want to get with a shoulder partner. You can be your shoulder partner. Or a shoulder partner real quick. Okay, so you two are going to be shoulder partners. May, your shoulder partner is going to be Sarah, and then Crystal and Amanda, can y'all be shoulder partners? Do you want to hop down one chair? Thank you. So, the first partner, all you're going to do is tell your second partner what you wrote on your paper. Talk about the questions. So, you're going to be partner 1, you'll be partner 2. Partner 1, partner 2, partner 1, partner 2. Partner 1, go ahead, and I'm going to start the 1 minute you're going to get, and I want you to tell partner 2 everything you wrote down for that question. Go.
I was reading. I was inside the circle, and therefore I'm part of the nucleus.
You're not part of the
Great,
nucleus.
I'm not outside.
You're a part of the.
Yeah, what color were you? Inside,
I was
outside?
pink. I was inside
Okay,
the
so
circle.
you turn it.
And I was part
Very
of the
nice.
nucleus.
I was part of the electron cloud.
Oh, I forgot she's here. Yeah, technically.
Okay, partner 2, go ahead and tell partner 1 what you did put on your paper.
So she was green.
I'm
She
blue,
was on the dotted line.
and
so
I'm
outside
inside
of
the circle. I was a part of the
And so she
nucleus.
was
So
a
the way that I was looking,
Go over
I
here.
feel like just going over
I was
things.
pink inside the
I
circle.
am the
The
nucleus.
nucleus. We are
Okay, 5, 4, 3. Start wrapping up. 2, 1. Okay, so we're going to get to what it means to be inside the circle and outside the circle. But remember I told y'all we were going to talk about some subatomic particles, because that was the definition of an atom. Do you remember that word? Subatomic particles make up an atom. Okay, so a subatomic particle, and y'all should have space to write this, is a particle smaller than an atom. A particle smaller than an atom. So some examples of subatomic particles are going to be the proton, neutron, and electron. Proton, neutron, and electron. And I'm going to tell you what those are right here. So as we said before, the whole slide represents, sorry, Shauna, your head is in the way. The whole slide represents an atom. And so we're going to take away that black circle because we don't need it anymore. That was just for guide, right? So I took that away. So raise your hand if you were blue. So blue, you were a proton. You represented a proton. And the definition of a proton is a subatomic particle located inside the nucleus. A subatomic particle located inside the nucleus. And I really want you to focus on where its location is. Raise your hand if you were red. You represented neutrons. And so neutrons are also located inside the nucleus. A subatomic particle located inside the nucleus. Amanda, where were they located?
Inside the nucleus.
Inside the nucleus. Did you already fill out these notes?
Yeah.
Oh, let me see. Wow.
Ta-da.
How did you know all the answers?
I'm gifted.
Oh, okay. And then raise your hand if you were green.
I was green.
Okay. And that means you were an electron, and an electron is located outside of the nucleus. So out of these three, the electrons are the kind of odd ones out. They're located outside of the nucleus. So we already went over the electron cloud, the nucleus. I'm gonna put these over other people's. Sorry guys, mine are important now. So the subatomic particles are what, Shauna?
Particles smaller than atoms.
Okay. And the three names for subatomic particles are.
Am I answering this?
No, hold on. Sorry. Are what, Crystal?
Protons, neutrons, and electrons?
Good job. Okay, so I want y'all to watch that video again because I want y'all to understand how small protons, neutrons, and electrons are. Oh. So as we said before, this whole thing represents an atom. This is specifically an oxygen atom. This right here, you'll see this is the electron cloud, and as we get closer and closer, it'll start saying it's the nucleus, and then look for the protons and the neutrons. This is where that whole bunch of nothing happens. And then nucleus. Then here are those protons and neutrons. And that's an atom. Really small. Do y'all want to watch the video again? No? Okie dokie. Okay, so outside, y'all had, if you were an electron, you walked in kind of a circular motion, right? On that dashed line, right? Okay, so what that meant was you were in orbit. So the difference between the orbits y'all were doing outside and the ones on the picture on the PowerPoint are that these are kind of able to go in multiple motions instead of just one way around. So an orbit is, I don't think y'all need to know this, yeah. Y'all don't need to know this, but this is just also a misconception that's often people don't understand. So the electrons revolve around the nucleus on a set path, and this is the distance. Point all these zeros within 529 centimeters from the nucleus. So that's why there's a lot of that empty space in that video where it said atomic emptiness. And then, so I think y'all already went over, does the atomic structure look familiar? And Shauna, you said it did, right? You said it looked like,
The solar system.
The solar
That's what I think
system?
my paper said.
yeah? Who
Yeah.
else put the solar system as something that looked familiar? Raise your hand.
I did.
Yeah? Okay, so the solar system is very similar in that it has a central part with other moving parts around it in an orbit. But the difference is, if you look at this picture, these are kind of like the rings we did outside, whereas in an atom, these are the orbits. where they can go in multiple, they're called planes, but y'all don't really need to know what planes are, but they go in multiple planes. Okay, so the title of the slideshow was called Pens. Does anyone want to raise their hand and guess what pens equals? Besides Amanda, because she already knows, so. Krista, I think your hand was up first.
Protons, electrons, neutrons, and subatomic particles.
You're right. So if you want to write this down, it's protons, electrons, neutrons equal subatomic particles, because all three of those are smaller than an atom. So protons, neutrons, and electrons equal subatomic particles. Okay, so flip to the next page. And it should say atom drawing with your name. So I'm going to give you a couple minutes. And so I want to see your atom. So I want you to draw an atom. It must include labeled parts. And I'm going to give y'all 3 to 5 minutes. And Amanda, since you got so far ahead, why don't you go ahead and start coloring your atom, okay? And if you want colored pens, I have colored pens for you to use. Do you want to make a P? You can tell me what P and D are. And don't forget your name at the top of the paper, guys, because you're going to turn this in. And if you need to, you can go up to the vocabulary wall and look at the definitions. My rivers are dangerous.
Do you know?
You like the colors?
Like this is the outdoors one.
Oh.
Oh, yeah. Oh. It's like the standard one. Those things are so good. No, the chocolate first ones. So what are you drinking?
Okay, guys, I'm going to give y'all 1 more minute.
Ice vanilla latte.
I just have my cream in it.
I was gonna do extra shot espresso and then I was like, wait, no, I don't need that much.
Okay, so get with your shoulder partner. You just had before in your discussion, and I just want y'all to talk 1 minute about what you drew and why. Sarah, will you come be? Yeah.
I like yours.
Or actually, you know what? Yeah.
Well, you can give yourself your
You can jump. It's up to you. You can be her partner, or you can jump in with the group.
I'll just go over there.
Okay.
It'd be easy on her.
I like that you have like a circle on the nucleus. That's easier to see than
so I drew
mine.
these and then I copied it.
I'll let her know.
I thought it looked so cool. Yeah.
So I was just.
But I just thought it was the two electrons here.
Well, like, I wanted to make it look
You
like
did it on yours too.
It looks pretty.
Oh no, this one.
Oh yeah, this one, that one.
I don't want to
No, I messed up.
oh,
That's
look at
okay.
her.
It's
She's
okay.
fun.
If you messed up, it could be my fault.
I like how you did space.
I just was coloring and I didn't realize I was putting in her picture.
Well, there isn't really.
John, why don't you discuss your paper with Myra, what you did?
Yours looks good too. You
But you
did a
had
better
the
job.
two girls walking in, so that's what this one was.
She's like, I just want two electrons.
Did y'all already tell each other what you did?
Yeah?
So I have my protons,
Oh,
neutrons,
I like the keys, I like the colors.
and then I have four
Well, I don't know how to put it in, so.
So one's going this way, one's going this way, one's going this way.
Okay,
I like that you
10 seconds. 5, 4. Okay, guys, start wrapping up your conversations. Start wrapping up your conversations. And then I just want you to rip that last page off. Make sure your name's on it because you're going to turn it in to me. And then the other one's going to go in your notebook for notes. Is your name on it? Is your name on it? And then last thing, before you leave, I need one question from someone. So at least someone raise your hand, and if you have questions about what we did today, what your partner discussed, any misconceptions, if you want me to play the video again. One question. Amanda.
Why do they call it a nucleus?
Why do they call it a nucleus? I don't know, but I'll get back to you on that. Any other questions? Okay, y'all have a good day, guys.